Lesson 14.1, Part B. We just talked about how having a number in front of sine caused your graph to go from a function like this and taking it and making it steeper. And it does that by a factor of 3. So where it was going as high as 1, now it's going as high as 3. And the same in the other direction. Okay, what happens when it's 0.5? Well, if we plug that into our calculator, and I go y equals, and we go to 0.5, and you graph it, it seems to have been squished, so to speak. Now the period has not changed at all, so what I'm talking about... Alright, sorry about that interruption. Okay. Now, it's been squished. Notice the period in either case has not been affected. It's just that the peaks and valleys have become either enlarged or made smaller. So this is getting closer to the origin. So it doesn't go as high, it doesn't go as low. So this one would be considered also a vertical stretch. You can say by a factor of 0.5, but really what's happening is if you look at this, it's the same as 1/2. Right? So you can say 1/2 also. Either one's fine, but by a factor of 1/2 or 0.5. All right. Now we're going to come back to these in a moment just to finish up some terminologies, but let's move on to what happens when the numbers are affecting x. So when it was out in front, it affected how high and how low it went. When it's inside, it's going to have a different effect. So let's take a look at that. So now this time we're going to go inside. We'll say 3x. Now you have your original right there, and here we have, it seems to have gotten squished, so to speak, in terms of like an accordion. So it seems to go up and down a lot more often. So here now the period has changed. Before it took 360 for it to start to duplicate itself and recycle. Now I can go right one down to here, and right out there it starts over again. Now this tick mark is 90, so it's greater than 90 but less than 180. We're going to figure out what that is later. But it shrunk it. Okay, so this is not a vertical shift, or excuse me, this is not a vertical stretch. This is a horizontal stretch. By a factor of, now it got smaller, so we're going to say 1/3, because it actually would repeat itself sooner. Okay, and we'll talk about that in a moment too. 0.5x. Now we're going to look at this as 0.5x. We're going to look at as x over 2, or 1/2 x, either one. But notice the difference. Here was 3 times x, and here it's x divided by 2, or it's being multiplied by something less than 1. Now in the last one, when we had a number less than 1 right here, it was squished vertically instead of enlarged. Now here we were multiplying by 3 and it got squished horizontally. Now we're taking it times something that's smaller than 1. Let's assume it's going to get stretched the other way. Then 0.5 and graph. Okay, so here's our normal one. period of 360. Now all of a sudden this comes in really slowly turning. Now that's doubled. Its period goes from here to here in order for it to start the process over again. So that one got stretched horizontally also, but it stretched it out instead of squishing it. So this is a horizontal stretch. By a factor of 2 because it got pulled. So the period's supposed to be 360, but it got stretched, so it's going to be much larger. And again, it seems the opposites here, but this has been the case for many times when we have something affecting x and in the parentheses. It doesn't seem to affect it the way we think. Okay? Now, the next page, we'll talk about the details. These are merely observations. Now here's an equation with sign, and it could easily be cosine. It makes no difference. But we refer to a number in front of the sign and the number in front of x in the sign. What happens? Well, A caused it, if you remember, to do this or shrink to very small, but never affected the period. So this is a vertical stretch. B caused it to either go very slowly up and down or repeat more often. So this is a horizontal stretch. Now they have some things that we're going to use. A vertical stretch, or A, affects amplitude. Okay, so if you were to do sound waves, you'd notice that something that looked like this was much quieter than something that looked like this. Okay, so when the peaks rise and shrink further, then this is basically how loud it is, or amplitude. So the number in front of the sign is going to be considered amplitude. And this part we will look at in a question that will follow. B affected the period. So what will the new period be? We will take 360 and divide it by B. And again, notice the amplitude is always positive, and so is the period, or B, when we plug it in. Now this could also be referred to as 2 pi divided by absolute value of B. And this is another formula. They look the same, but they've just solved for different things. This tells you what B will be if you want to have a certain period, and that will come up later as well. But again, this could easily be 2 pi over period. The same thing is discussed in the box. Notice that here we have lowercase letters. So in this case, unlike when we talk about arc sines and so on, inverse functions, it doesn't matter if it's a capital letter or not. Okay? Now again, if it's A and B, then you have amplitude and period. And here they have both units, pi, or degrees and radians. But notice this, if it's tangent, the amplitude is not defined, because you remember tangent went like this. It didn't have a maximum or minimum. It just kept on going forever. So that is why with tangent, amplitude isn't an issue. The period is also different, because if you remember, the period for tangent was 180. So instead of taking 360 divided by B, it's 180. It's what we start with, or pi. Okay, so in this particular example, we have A is 3, so amplitude is 3. Amplitude is 6, because we said it's always positive. Amplitude is 2, if it were sine and cosine. But since it's tangent, no amplitude. And here we have 4, so 360 divided by 4 gives you the new period. 5. Well, we said 360 divided by B or 2 pi divided by B. Either way, depends on the units. That is the new one there, and here's 3 pi. I'm going to stop here so I can fit it in, and that finishes part B.